Lustre client. We're going to be going over where it is today and what the roadmap looks like in the near future. So a little background on this work. So 6 years ago, EMC pushed this initial attempt to upstream Lustre to the staging tree. It ended up in Linus's tree. When that initially was done, that wasn't supported by the Lustre development community. The Lustre was no shape to be done. So EMC was the sole maintainer of that work, and after about a year, they no longer were able to maintain that work. At that time, Oleg was working along EMC to keep pushing that work, and he ended up for 2 more years maintaining that alone. Sometime after that, myself became involved with Ornell. I convinced Ornell to become involved in this work because this had positive long-term implications. That work lasted for the last 3 years I've been involved with this work. During that time, the Lustre Linux client became mature enough that SUSE actually attracted their attention, and now there is a developer, Neil Brown, who's been contributing for the last 2.5 years. While more effort is being put into the Linux client, we know that it was dropped out of the staging tree, and this was due to the policies of the staging tree and how Lustre itself is a pretty rapid target. It doesn't fit very well with the model of the staging rules. So now it's in a private repo where the work is continuing. Yep. And then by last year we were up to the 2.10 version. So how has it been since the last year? We went from 2.10 all the way to syncing to the OpenSFS master branch. We're pretty much in sync. We've been remaining in sync. With that effort done, that means that the work is now flowing. Instead of flowing from the OpenSF branch to the Linux client, it is actually now starting to flow solely in the other direction. This gives a lot of benefits to the OpenSFS branch as well, so the larger community end up benefiting. One is faster support of newer kernels, which in turn allows newer distros like Ubuntu 20 to be supported very quickly after release. Newer MOFET stacks tend to track also the latest kernels, so this actually ends up, by default, we end up supporting newer MOFET stacks. The other benefit we've seen, which has been large performance gains. So one of the things that was done during the 2.13 cycle was LU11089. During that time, there was a global lock on the LU objects that are handled, and Neil saw that upstream, and he broke that up into smaller locking and better handling. That was backported to the OpenSFS branch. In my testing, I saw a 15% improvement in metadata operations. The other work that was done on the LU objects was migrating from the libcfs hash table implementation to the R hash table implementation. That was done under LU8130. In the case of LU objects, we saw a 50% increase in metadata operations, except for stats. That was a doubling in our local testing. This was all landed for the 2.14 release, which will be shortly made public. And so those are the benefits of it. Over the last year, we've seen a community effort of working on this. Neil Brown from SUSE has been a major driving force in this work. Myself from Ornell, James Simmons, and Sean Tefan from Cray HPE have been actively involved in this work. And I would like to thank these people for their contribution. Without it, the project would not be in the state it is today. So now that we have it synced with master, the question to be asked is, how healthy is this client? Is it something that could be used for production? And the truth is it's not too bad. So we do active testing. So the testing that is done we do manually testing, and we do it against the master branch. Since the Linux Lustre client is now kept in sync, that means that we have the ability to use the same testing suite that is done. Currently, we have to run it manually because Malu isn't set up to build the utilities and the kernels. That has to be done. There's some work to make the Lustre utilities build against the Linux client, and that's being done under LU13903 and LU12511. There's some patches. This will allow you to build the OpenSFS tree just to build the utilities, and it'll use the local Linux Lustre client UAPI headers. So once that is done, we can actually work with WAMCloud to actually enable automatic testing of this work. This is, right now, the manual testing that's being done is Sanity LNet and Sanity testing. This is the same stuff that's being done typically for ARM and for Ubuntu as well. Out of doing this work, several bugs have been found in the test suite, and I have them listed there: 13017 and LU13933 and LU13977. A lot of those have actually already landed to master. These bugs affect the test suite. Neil finds an interesting way of finding these bugs that I don't usually see. There are also subtle client differences. The Linux client is a little different than the OpenSFS client. So one thing is that you can build it it's not modules. You can actually build it into the kernel binary image. That actually had to be updated also for the Linux kernel. I mean for the test suite. There is also the job IDs. So one of the key differences is that, like, currently Lustre allows the ability to scan the environment processor space to see what for environment and variables, and uses that to set the job IDs. That's considered a security risk by the Linux kernel developers. So they have actually not allowed us to do that. So what we've done is instead implemented session IDs, like you for TTYs, and you can do the same functionality. It's just an extra same step for the job IDs, and that's done in the Linux client, and it's also landed to OpenSFS. So our tests are updated. That's recently landed, so the test actually does it properly to handle the case where we don't allow process space scanning. If you look at the failures of these tests, you'll see the largest is due to the FID lookup cache. So there's a LSFS FID to path. This is very similar to the fhandle API that is standardized. There are some bugs in the way the dcache is handled, and that there's some tickets open for that. And because of that, a lot of dependency of getting the FID for testing is done, so that causes the most failures. So if these were resolved, it would only go down to a handful of failures in the testing. I've also started examining other tests in the test suite. So I'm trying things like HSM and the persistent client cache and other tests to see what kind of healthy state they are in. So with all that work going on, what is left for us to be actually able to become upstream and available and start to show up in distributions and other things like that? So what is left, we actually have, if you look at the slides here, we have actually a Jira link that tells you what are the changes left. So if you look at it, there's about 37 issues that are left. Some of those are big changes. If you can't see this link, you can actually look under the LU12511 ticket as well. That is tracking the same work. I try to follow that, what's left. So everything there is located if you want to examine what it is. The last barrier to actually that is blocking us from pushing to Linus's tree is actually IP version 6 support. So one of the things is for anything that goes into the network layer, there's a requirement that IP version 6 is supported as well as IP version 4. Currently, LNet only supports IP version 4. So there's a ticket, LU10391 where that work is being done. Some of that work has already even landed in 214. This is a very large project, and it's being slanted to land to Lustre 215, which is the next version. That is the big version, the big barrier. So if that was implemented, we probably would have been pushed to Linus's tree already. That was not the case. The other thing that we really do need, that's not an absolute hard requirement, but we really should have, since so many sites use IB, is to update the KO2 IBM LED driver. So that currently is not liked by the InfiniBand developers. Consider it too bloated and it does too much on its own. So it needs a rework and a diet. I don't think we can get it down to the 300 lines that Hellwig would like, but we can definitely get it much smaller than what it is today. And of course, outside of that, we want to squish as many bugs as possible as testing expands. And we would like to finish this before the 215 release, which would probably be the time when this would be pushed upstream. So what are the big ticket items left? So there's several big ticket items left, but so in the case of proc usage, so one of the big changes upstream is you're not allowed to pollute the proc file system namespace anymore. So that was required to be removed in the Linux client. That has been removed, so there's no proc. This does affect tools like that take advantage of things like job ID and stuff like that. So if you run your Linux client, you can see the impact of this. So in the upstream, it's all been moved to sysfs and debugfs. There's a limitation of debugfs that it's only root. So there's been some I've had some discussion with some of the developers about like how to resolve that so that sites can do statistical analysis, collect stats and things from the file system without using debugfs. So that way they don't have to run as root. And one of the main solution that came up was Netlink. So we're talking about Netlink, and Netlink has several advantages over debugfs. One is it scales, because you can multiplex the streams instead of opening many debugfs or procfs files. You just open one stream, but you ask for multiple. You configure it so that multiple streams are that contain statistics is put into one stream, and you receive that. The other thing is we have to enforce proper SFS naming. So one of the problems we've seen is that sysfs files tend to get named wrong. Not even just in the porting of proc to sysfs, but sometimes new sysfs files that were very similar to other ones were created, but they were misnamed with wrong spaces and things like that. So we need a way to make sure that new sysfs files or sysfs files that get moved behave as before. So that's a big project left to be done in the OpenSFS branch. The other one is the migration of the rhash tables to rhash tables and xarrays. So currently we use the libcfs hash table. It's extremely poor performance actually in the benchmarks I've seen with it. So we're looking to change everything that currently uses the libcfs hash table to an rhash table, as well as using xarrays. So xarrays is the extensible array API, which is a newer kernels. That is more for sequential data. So there's some areas like in the HSM handling code on the MDT, you'll see that the data is actually sequential, and if the data is sequential, it's not the best idea to use a rhash table, but xarrays actually works really well in that kind of case. So it should give a great performance boost, and we've seen this with other things. The LNet self-test needs to be reworked. So currently it's in no shape to be pushed upstream. The other problems, it just doesn't work very well for newer kernels and on ARM and that. We've seen a lot of problems with it. It needs a rework, and I would like to do it with using the Netlink API that's being developed. So this allows us to do, I would love to see the ability not just to do simulated network traffic, but allow Netlink using Netlink the ability to monitor live LNet traffic and to see its behavior in real time. And another couple more issues that we've seen is the sysfs file names are not ASLR compliant, so it's considered a big no-no to expose pointers to address spaces into user space from the kernel. That's considered a security hazard. We do that for our sysfs files. So there's a ticket, LU13118, which is going to be looking at removing that and moving from using these pointer addresses to using like a UUID. That also gives us the benefit of allowing file system mounts that are consistent across reboots, as well as the same UUID to be used on ARM as well as on x86. So there's going to be more of a uniformity. Right now that the address pointers are very, very different across these architectures. And of course, the last large problem is the FID lookup cache. So there's a lot of work that needs to be done to fix that, for how the Dcache handles it. It also doesn't work with files, with file sets. So if you do a subdirectory mount, you can't access the FIDs. And so those are things that are looking and to work. Additionally, things like fhandle doesn't behave quite properly. And so we're hoping to address that in the next Lustre version. So once a lot of those things are worked out and this is pushed upstream, that means the future is going to change a lot for the Lustre community. So once it's in Linus's tree, it won't be too long before it starts showing up in new distros. This is a very advantageous point for us, especially since one of the things Lustre likes to do is use all Sims, which exports things that aren't exported, and you can't do that out of tree. And recently, that functionality has been removed in newer kernels because they don't want to encourage long-term kernel projects outside of the kernel tree. They want you to actually merge upstream. The good news is that once we start showing up in new distros, since Neil is actively involved in this project, he will actually, SUSE will give good support for this. The other one is Ubuntu. Ubuntu is an unknown. A lot of volunteers work on that project. It is the closest to upstream. So when that goes out, we're going to see any bugs we see there is pretty much going to be the closest to what any upstream bugs are. So when we fix it, it'll be backported pretty quickly. It's just a matter of getting someone to support the utilities and putting it in the packaging and getting it blessed by the Ubuntu community. And lastly, of course, we always have Red Hat, and Red Hat is the main focus of the WAM Cloud development team because currently that is the largest user in the HPC community. Usually it's several year cycle, so in probably 2 years, we'll be starting to see it show up in the next Red Hat version. Assuming that we push, it gets all merged by the end of the 2.15 cycle. One of the nice side effects of doing this will be the new developers will enter the community. So one of the nice things, even when we were in staging, we saw people actually resolving bugs and issues. They saw bugs that we didn't see. And this was actually very helpful. There's also this unique ability of the Linux Lustre client to show bugs that no one else can see. I've seen this behavior also, the same with ARM. So this is going to be very useful to have this new feedback, as well as new eyes looking on the code. This will be a great benefit to the community. With that done, the next step will be to, of course, complete the transition of all the kernel code from the OpenSF tree to the Linux kernel tree. The major hurdle is probably the LDiskFS support. So Lustre extensively patches ext4. So we've been put over time though. Andreas Delger has been doing a great job of pushing that stuff upstream. So we've been shrinking it. So hopefully by the time the server code gets ready to be pushed, we'll be having most of it done. And we won't need to patch ext4 in the near future. One of the big changes too, a proposal has been to do parallel directory lookup in the VFS layer, and that's a link there in the patchwork that was posted, and that's probably something that's going to be explored, so we can do have that as a larger benefit to the overall community. And of course, as everything gets backported from the Linux Lustre client, all the changes, any changes that overlap with the server code is already done in the OpenSF tree. And this gives the benefit that it's a much smaller transition. So while the client is a huge job, and it's taken many years, the server code is going to be a much shorter window to bring that upstream. With all this work being done, and the idea of the client becoming a real reality as we prepare for the 2.15 timeframe, we really need people. It would be a benefit that people would actually test and experiment with this branch. And of course, the community is welcome to look at this. So we need greater scope of Lustre testing. The testing is needed to expose very unique bugs that we see. So how do you do the testing? So there's a GitHub that Neil Brown, he's hosting the Lustre tree. We have a wiki at lustre.org on testing. It tells you how to set up the test suite and do everything. And of course, if you find any bugs, please report that to the Jira ticket at WAMCloud. There's the dashboard. And when you do report the bugs, please add a label upstream so that we can see it and it's identified as a Linux Lustre client issue. And of course, outside of testing, as well as testing, if you have any questions how to set this up or what to do, feel free to email us on the Lustre Devel mailing list for lustre.org. There's a link there. You can actually look back. It's not a heavy, you will not see a lot of email or things like that being posted there. So it's a low level list, so you won't see hundreds of emails per month. You will see occasionally a batch of patches come in from the Linux Lustre client, but that's about it. And of course, people are always welcome to join the Lustre working group for your company. And also always feel free to send people to Lustre conferences. We had Vlad, such as this, and Lugs in the US and in China as well. So to present your work or to ask any questions, usually we attend these events. So the conclusions about this work: the client mostly works. It's synced to the latest stuff. And it's pretty close to merging to Linus's tree. These are all huge benefits. Very soon you'll be able to just make all this work out of the box. Of course, to make this the best possible product for people to use, we welcome community support. You can join OpenSFS if you're looking to contribute. Don't be afraid to ask questions or report problems. There's LWG calls. People are welcome to participate. And we have the Lustre Develop mailing list, as I noted before. Feel free to report bugs, or you can contact me directly at jsimmons@infrared.org. That's my very old Linux kernel development email address. And finally, I would love to give a call out to the U.S. Department of Energy, which has a contract for this work. They have been very supportive of it, and I would like to thank them. Thank you.